Hello, my name is Hayashi from Caulis. Thank you for this valuable opportunity today. Let's get started right away. So I explain about from Redis to Aerospike supercharging fraud detection with scalable NoSQL. Here is today's agenda. First, I'll talk about our company and myself. Next, I'll cover the use case. The key points are required for the database, the result, and then a summary. Yeah, background of Caulis and me. Yeah, hi, I'm Yasu. I'm the development team leader at Caulis. We went public in March 2024. Yes, thank you. I've enjoyed working as a software engineer for about 12 years as a DevOps and SRE engineer for 7 years. In my career, I worked on the retail IT team at Nike Japan when I was younger, and also on the operation team for Rakuten's membership services. As a backend developer, I've used Ruby, Perl, PHP, Python, and C Sharp. Recently, I've mostly been working as a DevOps and SRE team, also engineering manager. I have experience with commonly used technologies. Yes. So about the Caulis, Caulis is a company with a mission to create information infrastructure and make the world a better place. Our main product is a fraud detection solution called Fraud Alert, which was being widely adopted by many customers in Japan. I'll explain Fraud Alert in more detail later. We share fraud data across industries, collaborate with the electric company industry for practical implementation and advanced public-private partnership to provide a secure internet environment as a social infrastructure. Fraud alert from Caulis supports customers in preventing crimes by determining the authenticity of all customers' touch points across industries, companies, and devices. Future plans include in targeting with ATMs and IoT devices. Here's explanation of how fraud alerts function in stages from the beginning. Yeah, uh, Initially, it starts with rule-based fraud detection. As the data increases, it's utilizes this data for risk-based detection. For example, if information different from the usual login environment is detected, it returns an alert to the customer as an API response or email notifications, assisting in monitoring and blocking. Fraud Alert offers seven services: login detection, phishing site detection, in integrating with information provided by select electric power companies and fraud transfer detection, screen transition detection, new account opening detection, and consulting on how to utilize these products for monitoring operations. These form the fraud alert services. The customer can pick and choose which services they wish to use. We use the for we use the we use data from customers, feedback from Fatov forums. I'm not sure you guys know about Fatov or not, and regulatory sandbox initiatives to evolve our services. Not one. The regulatory sandbox is a Japanese initiative, and not two. The person on the right in the top right photo is our CEO Shimazu. On the left is our CEO, CTO Sue. Here, the next I'll explain the use case as this is real-time data summit. We'll focus on how we utilize data in real time and why real-time processing is essential. This slide roughly shows how fraud alert is used. It starts on the right side, we obtain information from the end user and receive requests from customer authentication server, write and retrieve data from Aerospike, process it with various algorithms and machine learning, and finally return it to the customers. I mean that it's not end user, it's our customer. The speed isn't extremely fast, averaging 100 milliseconds, with a percentage 99.9 percentage latency of the 500 milliseconds. Traffic peaks around 1700 to 2000 QPS, query per second. Yes, which isn't too high. I think. But marketing traffic is much higher. However, we need to provide complete, real-time, and rapid response to financial institutions. Criminals act quickly, making timely notifications essential to mitigate damage. Yeah. From this point, I'd like to explain key requirements for the database. So it's better to explain about the past. So first, let's look at the past. Yes, version 1, we used a Redis cluster. Version 3, it's a Redis cluster or version 3. So version 4 was available, but we could not use it for various reasons. So Redis has several advantages. As many of you know, it's fast, and schema management is easy. And since it's KVS, I mean that key value store, yeah, clustering ensures that if one node failed, the system remained operational. Yeah. Yeah. However, challenges with version 1 included. I'm not sure it's a common usage, but I'd like to say that scale out and scale in could not be achieved without downtime. I mean, about the scale out means horizontal distribution was problematic. Yes, restoration required downtime. This is also is needed the downtime. We needed a continuous service, making this difficult. Yes, and backup files sometimes corrupted, causing long recovery times and data errors. And clustering was supposed to ensure resilience, but yeah, re-adding instances to the cluster sometimes caused instability. Finally, understanding and correctly using the clustering systems was complex about the Redis. It's not other product. Yes. Despite seeking advice from a Redis professional and conducting various tests over 2 years, we concluded that solving these issues with our unique use case was too difficult. So we began considering database migrations. So yeah, about the key capabilities required for migration. Sorry, horizontal and vertical scaling without downtime, and seamless restorations. And next one is reliable backups and easy to manage system. Yeah, cost performance was also crucial. Initial operational migration and downtime costs. This point is 4. Yeah. So at the time, our product needed to work to fit our target market, making cost a significant factor. So a wrong decision could have led to bankruptcy. Yes, we considered three options: DynamoDB, Aerospike, and Aurora. And DynamoDB was a managed service with AWS support, reliable and fast. But its request-based billing posted cost risk. Yes. And Aerospike was a new technology with potential operation and maintenance challenges, but offered easy cost calculation based on the data sites. Yeah, enterprise support was also available. And the last one, Aurora, it's a family RDBMS, was a managed service with AWS support and easy cost calculation. However, it required strict schema management, which was a drawback at that time. Yes. So, we ultimately choose Aerospike. During testing, we used AWS traffic. This picture showed how to test and how to validating behavior with live traffic. So we used AWS traffic mirroring to compare Aerospike and Redis, ensuring consistency in detection result and performance. Production requests were directed to the Redis API, and while mirrored traffic was sent to Aerospike for comparisons. Yes. So, final decision factor included the maintenance, operation, and support, with no significant difference among Aurora DynamoDB and Aerospike. I mean, this were. Yeah. Production requests. Sorry. Sorry. Cost performance was deciding factor, including development costs. We needed cost-effective first, well-supported solution. Redis was nearing its data size limit, risking write failures, and we had to act quickly to avoid service disruption. So this point, Aerospike was far more cost effective. Aerospike matched Redis speed in all tests. Yeah, I verified. Past right. Yes, Aerospike provided rapid support and solutions. Fast deployment was essential. I mean that this that's why we need to do quickly. Yes. So as a result, Aerospike provided satisfactory speed, stability, ease of operation, and reliability. So I was relieved to be free from our data worries. Yes, this shows when I overed this project. Yes. However, I want to make this clear. Yeah, Redis is excellent product. I don't intend to discredit Redis. It's outstanding for caching and handling non-permanent data. So our use case involved semi-permanent data. So making Redis unsuitable. I don't know why this use case was chosen because uh, I was not in Caulis when uh, our member choose this one. Yeah. So Aerospike handles atomic data and works as a key value stores, which is clear difference. Yes. So in a summary, yeah, fraud detection must be real time, and the fraud alert requires stability, easy of use, and real time performance. Aerospike delivered this. Yeah. Thank you so much. And different databases, including Aerospike, Redis, and RDBMS, have their strengths. I think, I believe that one. It's essential to choose a database based on use case. Yeah, business needs and organizational sites. Yes, I believe so. So I hope this has been helpful. Thank you for listening. Thank you.